All right, so we are going to be working on our next section. This is about the shape, center, and spread. And here's our essential question: which measures of center and spread are appropriate for a normal distribution, and which are appropriate for a skewed distribution? Okay, so here we go. We have our standard for mathematical practice is to reason. Specifically, we're going to look at numbers and symbols and what they represent. Then starting right at the top on your textbook packet, seeing the shape of a distribution. Follow along as I read. We're going to also highlight. So if you have a highlighter, or you can underline as we go. So raw data values are simply presented in an unorganized list. When we organize, just kidding, let's go back. Organizing the data values by using the frequency with which they occur results in a distribution of the data. Okay, so that's how we get our distribution of data, is to organize it. Okay, so a distribution may be presented as a frequency table or data display. Data displays for numerical data, such as line plots, histograms, and box plots, those are our type of numerical data displays, involve a number line. So I'm going to highlight that as well. While data displays for categorical data, so that's a different type of data we talked about previously. And come on, honey, highlight for me. There we go. Okay, such as bar graphs and circle graphs do not. So they do not, I'm sorry, I lost my train of thought. Involve a number line. There we go. They do not involve a number line. So data displays reveal the shape of the distribution. So this key right here is we're talking about the shape. If it will let me highlight, that would be fabulous. I don't know why it won't. There we go. The shape of the distribution. All right, so then we're going to go forward and see if we can get the tablet to agree. And we went backwards, forward. One more. There we go. Okay, so this first part, part A, it says the table gives data about a random sample of 20 babies born at a hospital. It says make a line plot for the distribution of birth months. So our focus right now is only on birth month. Okay, so we're going to record that data and we're going to organize it in the number line. Here's how we do that. We take the first one, which is 5, and I write a little X above the 5. Then the same thing for the 7, for the 11. You guys can do this with me on your paper. With the 2, now I have 10 and 3, 1, 4, and then I run into 7, which I've already marked 1. So I'm just going to stack another X. This is my way of changing slides, apparently. There we go. This is my way of saying there's been more than 1. So I just stack it and I continue 6 and 9, 10. That was the next one. 11, 1, 6. And I'm going to stack it again. 5, 8, 9, 12, and 2. All right, so when we're finished, we have this picture of our data. This would be a distribution, and we're looking at the shape. And if you look at the shape of the X's, it's fairly flat. There's not a lot of hills nor too many low places. It's fairly even. So I would say this is very evenly distributed. I also might comment that it's pretty much the same across. So the same across the data. Like there's nothing that really stands out. All right, so then I'm going to go forward. Actually, you guys are going to go forward. And continuing on, you're going to do parts B and C on your own. And you can check that on PowerSchool. I'll have the worked out solutions for you. So we're going to jump over to the reflection questions. And I want you to answer these based on those 3. So describing the shape of the distribution for each different one. So keep in mind on that first one that we did together, that I just did for you. This one, I commented that it was evenly distributed. Lost the I there. The same across. And so those other ones you're probably going to see, just to let you know, you're probably going to see a cluster or a clump of data in one section. So you want to comment on that, what you see in terms of how the data is laid out. What shape does it have? Okay, so then once you finish that, then we're going to continue on and read a little bit more. So explore 2. Again, make sure that you did do the reflection before you go on. All right, so we have relating measures of center and spread to the shape of a distribution. As you saw in the previous Explore, data distributions can have various shapes. Some of the shapes are given names in statistics. So a distribution whose shape is basically level. So that was my evenly distributed one, the one I did with you. And why won't it give me my pen? There we go. That looks like, kind of makes it look like a rectangle across. This is called a uniform distribution. And then we have a distribution that is mounded in the middle with symmetric tails at each end. That it looks like a bell-shaped. It used to be the bell-shaped curve. That's a normal distribution. So down here, this is the one that says symmetric. This is our normal distribution. Then we have a distribution that is mounded but not symmetrical because one tail is much longer than the other. It's called a skewed distribution. So the side where you have the tail, that's how you know it's skewed left. And then, of course, the tail over here, it would be skewed right. And those are some general pictures for you to think about. All right. Then on page 1097, continuing, shape is one way of characterizing a data distribution. Another way is by identifying the distribution, center, and spread. So those are going to be important words, center and spread, and we're going to talk about them quickly. So we've done mean before, and we've done median before. These two are both versions of our measures of center. So they're different ways of describing the center or the middle of the data, mean giving us the average and median giving us the literal middle. Okay, and we're going to talk about when to use which one. So they're both trying to measure the same kind of thing. Then we have standard deviation. Whoopsie, come back. We have standard deviation and interquartile range. Don't mind the bell in the background. I'll wait for it to finish. Okay, so the standard deviation we calculated previously. Interquartile range we're going to learn about today. But again, both of these are going to measure spread. Okay, then continuing forward just a little bit more. We have at the bottom there, it says to distinguish a population mean from a sample mean, statisticians, use the Greek letter mu written as mu instead of X bar. So this one is for a population and this one is for a sample. Okay, and then if we go to the next one, similarly, they use a Greek letter sigma written as this, sigma, for a population. And they use just a regular S for a sample, okay, to distinguish the two different types of deviation. All right, then this part says to use a graphing calculator, but I want you guys to use Desmos. So using Desmos, you're going to enter into a table we're going to work with the baby weights is one of the things, and then the mother's ages. So we're going to build two lists. When you are on Desmos, and I apologize, I'm not pulling that up, but you have, when you put in a table, your table at the top says X1 and Y1. You can put both sets of data in at the same time. You can make your baby weights the X1 and your mother's ages can be the Y1, and then you don't have to do two separate tables. You can just enter your data under those headings. Okay, so you're going to enter those in on your calculator, then on your Desmos calculator. Then you're going to calculate, this says I variable statistics. This is if you're using a graphing calculator, which we are, but not a normal one. We're going to use Desmos. Okay, and this one we're going to focus on the baby weights, which is our X sub 1 group. Okay, and then we're going to just find the statistics that are at the bottom. So these we can find, remember for X bar, that's finding the mean, and that's what you type in onto Desmos. You're going to find the mean of X1. That's your command in Desmos to find the mean, and I'm going to write that a little neater for us. Okay, so we have, for this one, it's find the mean, and there goes announcements. Ignore that.
Please stop by the reception desk. You have items for pickup.
Yay, we're going to listen to the people that are picking up their items. All right, then for the median,
Gael Gomez,
this one, we're going to type in median of X1. And then for the standard deviation, This one,
Sarah
it's
Mayorga
saying
and
S,
Antonio Gardea.
but we're going to type in ST for standard, then DEV, deviation, and we're going to put the P for population only because what we're entering in, even though it's a sample, we want to use all the values. So that's the way the calculator is going to understand it, to use all the values. And again, this is for X1. And I don't know why I put parentheses the way I did right there. I apologize. These should only be around the variable. I don't know what I was thinking. Sorry about that. Distracted by the announcements. There we go. Okay. And then for the IQR, this one, in order to calculate it, you have to type in, not that. We'll talk more about the IQR and explain it a little bit better. But for you to calculate it using the calculator, you have to type in the word quartile. And then you do X1, I believe a comma, and then you're going to say 3. That's saying interquartile or quartile 3. So X1, comma 3. Then you're going to say minus quartile. X2. I'm not sorry. We're not doing X2. I apologize. Our list is X1. And then a nice comma. And then 1 to say quartile 1. Okay. And that will give you the values you need in order to do B. Then you're going to go to C, and we're doing the same thing again, this time for your list. All of your X1s, you're going to turn them into Y1s basically, because the mother's ages were our Y1 column. So you can just type in those same commands from the previous slide. And then I want you to answer these reflection questions. And that takes us through the lesson. If you have questions, I will post the answers for all of these so you can check your work later. But please try them because you are going to be held responsible to do them in Desmos later. Okay? Thank you guys so much, and happy homework. Make sure you get your homework down and do it.